Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine an AI agent dropped into a Linux terminal. No GUI, no hints, just a blinking cursor. This is the world of the paper on data engineering for scaling LLM terminal capabilities by Renjie and Grace Lam from NVIDIA. And it's a story about how data, not just model size, unlocks real terminal intelligence. Here's the problem. Large language models are getting better at coding, but terminal interaction is a different beast. Benchmarks like Terminal Bench require full workflows, compiling code, debugging environments, configuring systems, and yet the real training data behind top terminal agents mostly undisclosed. So the authors ask a bold question. What if scaling terminal capability is really a data engineering problem? Their answer is a two-stage pipeline called terminal task gen. Stage 1, dataset adapters. They take existing math, code, and SWE datasets and wrap them into terminal style tasks using the Terminus 2 format. Stage 2, synthetic task generation. Here they go further. They generate brand new tasks in two ways: seed based, inspired by existing problems, and skill based, built from primitive terminal skills like file IO, debugging, security, and data science. Tasks are Dockerized, verified with Pytest, and critically, solution information is never leaked. The infrastructure is serious. They use pre-built domain-specific Docker images. This avoids generating thousands of Docker files. It's scalable, efficient, and clean. The teacher model, DeepSeek v3.2, it generates trajectories inside these environments. Now here's the twist. They don't aggressively filter bad trajectories. In fact, keeping incomplete or even failed runs improves performance. Why? Because models learn from error states and recovery patterns. Strict filtering cut performance nearly in half. That's counterintuitive, but powerful. And the results? Nematron Terminal 32B jumps to 27.4% on Terminal Bench 2.0, beating much larger 480B models. Even the 8B model improves fivefold over baseline. And category-wise, data querying jumps from 0 to 60%, model training from 0 to 50%. This isn't just scaling parameters, it's scaling trajectory quality. They also test long context training, up to 65K tokens. Turns out it doesn't help much. Most useful supervision fits in the standard window. Longer context just add noise. Curriculum learning, also no big gain over simple mixed training. But scaling data volume, that clearly boosts performance. So what's the real takeaway? Terminal intelligence isn't magic, it's engineered. Through structured adapters, skill taxonomies, Docker environments, and carefully curated trajectories, and maybe the future isn't just bigger models, but better data pipelines. What happens when we combine this with reinforcement learning next? That is the next frontier. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.